All right, guys. So today you're going to do a little warm up from stuff from last class, the special right triangles. Then we'll do the notes for 4.2. It's all about radians and degrees, different ways to measure angles. We'll do some quizzes in class for practice. And then you've got Delta Math homework and you have a long weekend. Okay? Guys, anybody questions before we get started? All right, get out whatever you're taking or doing your warm up on. All right, guys, so you are solving for x and y. Try to squeeze those formulas in there for you. So again, this is from last class, the special right triangles. Give you some time to solve this. You have a pass, look at that. Good job, Ed. in with your neighbors, guys. See how you're doing. Which one? No. Like in number 2. Yeah, no, go with the angles. X is the short side in number 2. Short leg. In number 2, because it's across from the 30-degree angle. The third one looks a little more like the short leg. Are we ready, guys? Testing our multiplication skills today. Yeah. All right, guys, let's go through these and see how you did. So number 1, that's a 45, 45, 90 triangle. What do we know about the 2 legs? They are the same. And so I look at the formula. I know the hypotenuse is equal to root 2 times a leg. So either root 2 times x or times y. I divide by root 2 to solve. Rationalize. Sorry, I don't have a lot of room here. And you get both x and y. You get 8 root 2 over 2. Is that our answer? Yeah, so x and y both equal 4 root 2. We do okay on number 1? Yeah, okay. All right, number 2, the 10 root 5. Is that the long leg, short leg, or hypotenuse? That is the long leg. So you need to use the equation that has long leg in it. So 10 root 5 will equal root 3 times the short leg, which in this case is x. So you're going to divide by root 3. When I rationalize, and I know I'm squeezing this in here, that gives me 10 root 15 over 3. Can we see it? Question, Alex? Or okay. Got to multiply your square roots. Renata, okay? For sure. Yeah. Okay. All right, so that's the short leg. How do I find the hypotenuse? Yeah, multiply by 2. So I'm going to get 20 root 15 over 3 for y. All right. We good on 2? Anybody questions on number 2? All right, number 3. What did I give you this time? hypotenuse. So I need to use the formula that has hypotenuse. So 8 root 6 equals 2 times the short leg, so 2x. So when I divide by 2, what do I get? 4 root 6. So there's the short leg. That part's pretty easy. How do I go from short leg to long leg? So y is going to be 4 root 6 times root 3. So I'm going to get 4 root 18. I can't leave it like that, though. You have to be able to simplify your square root. So 18 is 9 times 2. What's the square root of 9? So this is really like 4 times 3 on the outside, root 2 on the inside. You don't have to show all of these steps. This is just me making sure you know how to simplify a radical. Okay? So it's 12 root 2 for the long leg. Anybody questions? We good? Okay. Well on your way to your A, right? All right, guys. Anybody? Anything before we jump into the notes? Notes today, we have a decent amount of definitions, so just bear with me through those, and then we'll get into the quizzes. The quizzes. The quizzes. Yes. Quiz is. Oh my God, get rid of all that. Nothing scary at all. Angles and their measures. The little XY grid here is all here. I'll draw some angles and label things for you. Okay. All right, first definition is the initial side. So we're talking about an angle here. The initial side of your angle is just where the angle begins. So for everything we're going to do, that's going to be on the positive x-axis. So like the right side of the x-axis. So I've drawn a little angle over here. That is the initial side. I mean, it's up to you. Do you want the picture with everything labeled? Okay, then write it down. And guys, let's go ahead and shut your laptops right now. Nobody needs them for anything. So what does it say in parentheses? Okay. There you go. Ready. Laptop shut, guys. Thanks. All right, angles also have a terminal side. What do you think the terminal side is? Where it ends. Yes, where the angle ends. Now that's not always in a certain place. Your angle can end anywhere in your quadrant. So this is the terminal side. And then just as a refresher, guys, what quadrant is that terminal side in? Second quadrant, that's quadrant 2, okay? Remember, this is 1 over here on the right side. 3 is the bottom left, and then 4 is the bottom right. All right, I can have a positive angle. And this happens when the angle travels counterclockwise. Hopefully we all know counterclockwise from clockwise. Concerning. Look at the clock if you need to. So let me draw an arrow here. So if I go from the initial side to the terminal side in that direction, that's counterclockwise. I'm going to call this 120 degrees. I think we all know if it was straight up and down, that'd be a 90-degree angle. This is a little more than that, so we'll call it 120 degrees. All right, I can also have a negative angle. What do you think happens with a negative angle? Yep. So let me label up here. If I start at the initial side and travel to the terminal side going in the clockwise direction, that's going to give me a negative angle. Anybody think they know how big that negative angle is? Negative 240, exactly. How many degrees are in a circle?
27.
360. So we know we're going backwards there. Hey, Henry, can you put your laptop away? All right, guys. So that's the difference, positive, negative angle. They're in the exact same spot, but how you label it tells you what kind of angle it is. All right. Another definition, we have what's called a quadrantal angle. And I know that sounds like I just made up a word, but I didn't. The terminal side is on the X or Y axis. So for example, 90 degrees, that is a quadrantal angle. So like it doesn't end up in a quadrant, it ends up on an axis. Yeah. Okay, does that make sense? What's one? So if you think about it, so like 90 degrees, right? That angle. What would be over on the left? 180. What about at the bottom? Yep. Oh, sure. That super nice drawing I made. Yeah, of course. All right, so let's try a couple of examples here. All right, we are going to draw each angle. Name the quadrant. So like, where does the angle end up? We'll do A together and then I'll let you try the rest on your own. Yeah, child. Yep. For everything we will do, yes. All right, guys, so 55 degrees. What quadrant is that going to be in? 1. So you're going to draw, there's my initial side. 55 would be just a little more than halfway through the first quadrant. I'm not looking for perfection here. Just something roughly like that. You can throw the little arrow in so we know which way we're going. And tell me quadrant 1. Okay, so just a little picture for me. You guys get to try B, C, and D. All right, so I'll give you a minute to try those 3. Check with your neighbor. Do your pictures match? How are you doing? Are you stuck on one? It's more than once around the circle, right? So you got to figure out how much more, and that's really the angle you're drawing. Mm-hmm. Yes. Yep, that's what determines the quadrant. All right, guys, let's go through these. So negative 180, there's your initial side. You end up in the same spot as positive 180. We're technically going backwards, though. Does this one? Yeah, we shut that. Thanks. Does this one actually have a quadrant? No. What kind of angle is that? Quadrantal. Good job, guys. Okay. 280. Where is 280 going to end up? Fourth quadrant. Yes. Just a little bit past. That was really close there. That way, 280, and we are in the fourth quadrant. Okay, D was a little different. 425 is obviously bigger than 360, so it's more than once around your circle. How much more than once around the circle? So you're really just figuring out where you would draw the 65-degree angle. The only thing you might want to note to show that it's not just 65, when you draw your little arrow showing the direction that you're going, it's like a little spiral, so it goes around more than once. And then first quadrant is what we would make. I think it looks like a little snail. I don't know what you mean by 3 and 4. C and B? C? B is quadrant. Right. I didn't ask you to name the type. We haven't talked about any types of angles. I've said name the quadrant. I said draw each angle and name the quadrant. All right, guys, another definition for you. This one's a little wordy, so get it all written down, and then I'll explain the words and give you a picture and all of that to go with it. So we are going to define a radian. It is the measure, radian, R-A-D-I-A-N, of a central angle whose intercepted arc is the same length as the radius. So again, jot it down and then I'll explain more, okay? Okay, guys, so what is a central angle? Henry, no, put your laptop away. Put it in your bag because you're just going to open it again. Thank you. All right, anybody, what is a central angle?
Are we doing it for more too?
Yes. So the angles we've drawn.
The point is 0, 0.
Yep, the origin is where your vertex is. So a central angle is on the vertex here. So that's a central angle. Okay, do we know what an intercepted arc is? So the angle that I've drawn, like the part of the circle that it cuts out, kind of like the crust of your piece of pie, if you were to cut out that piece of pie, that is your intercepted arc. Okay. That is the intercepted arc. Okay, and what we're saying for a radian is that if the intercepted arc, it's curved, but if I could like flatten that out and measure it, the length of that arc would be the same length as the radius. Okay, does it look pretty close? We could actually do this with string, but we're not gonna play with string today, so we're eyeballing it. That looks pretty close to the length of the radius. That angle in there is 1 radian. You're used to naming angles with degrees. Radians are just another way to name an angle. It's like distance. You could measure it in inches or feet. You can measure angles in radians or degrees. Okay. Now, something interesting. There's 1 radian. I'm just going to approximate and mark off a few more radians around my circle. That looks like maybe 2 radians. Not exactly. By the time I get over here to where 180 degrees is, it looks like I'm at 3 and a little bit. Do you know a number that is 3 and a little bit? Pi. So that is why 180 degrees is the same as pi radians. Okay? If I kept going, 4, 5, 6 and a little bit more, what would 360 degrees be the same as? Yeah, 2 pi.
That's actually really interesting.
Mm-hmm. And we're going to use that pi versus 180 all the time.
So all this takes radians?
Yes. Like, if I had, just imagine I had like something marking this, and then I take it and go, okay, from here to here, and mark it off, and from here to here, like measuring my way around the circle. Anybody questions or need me to say any part of that again? I know it's different and new for you guys. Yeah.
Does the radian have a specific angle measurement?
So, saying, like if I said the angle is pi, you would know that's the same as 180 degrees. There's no like little symbol for radian like there is with degrees, but they are equivalent to each other. It's like saying 1 foot is 12 inches. 180 degrees is pi radians. Okay? We're going to use that when we do some converting. That is what we will do next. All right, so we're going to convert. First, we're going to go from degrees to radians. So I think I'm on number 2.
Should we be writing this down or not?
These are your notes. All right, so we're gonna do the first one together, and then I'll let you guys try. So I'm gonna start with 70 degrees. Okay, so when you're doing conversions, you guys have done this before. Like, let's say I wanted to know, I had 20 inches. You don't have to write this one down. And I wanted to know how many feet that is. You would take 20 times 1 over 12, 1 foot over 12 inches, right? If you want to convert that to feet. Okay, 1 foot and 12 inches are, it's essentially a fancy way to write 1. That's what we're going to do here with our radians. So if I want to turn it into radians, I need the radian part in the numerator, the degree part in the denominator. So whatever you're trying to turn it into is in your numerator. You can also look and go, okay, my degrees would cancel out, which is what I want. And then it's just a matter of reducing your fraction. And yes, you would be doing all of this without a calculator, guys. So 70 over 180, what does that reduce to? 7 over 18, yes. So your answer here, in terms of radians, is 7 pi over 18. No, it's not too bad, right? All right, so let me give you a couple more to try. Try 210 degrees for me. And negative 150 degrees. Do you think the negative really does anything? No, it just means you have a negative on your radian as well. So I'll let you try those two. Yep. If you're converting from degrees to radians, yes. If you're going from radians to degrees, what do you think you'll be multiplying by?
Radians to degrees.
So 180 over pi. 180 over pi. If you're going the other way. Check in with each other, guys. Do you have the same thing? All right, guys, let's go through them. So 210, I am taking times pi over 180. And if you're struggling at all with the reducing, do it in steps. Like this one, right away you can divide it by 10. So you'd have 21 over 18. And then what does that reduce to? Yeah, so your answer is just 7 pi over 6. Okay? All right, the negative 150 times pi over 180. What do you end up with when you reduce that one? Good. Not too bad? Okay. Let's convert the other way then. So let's go from radians to degrees. Let's do this one together. So if we start with pi over 6, guys, I want to end up with degrees. So what am I going to multiply by? What fraction? Yeah, you're just going to flip it because now you want the degrees in the numerator. That's what you want to end up with. And again, reduce. What's going to happen with the pi's? Yep. And then what is 180 divided by 6? So it is 30 degrees. Okay? Make sense? Yeah. Just lots of reducing here. Give you a couple to try. Let's try 3 pi over 4 and negative 5 pi over 3. Now guys, make sure you reduce before you multiply. Like I don't really want to do 3 times 180 or 5 times 180. Do the divided by part first. 180 divided by 4 or 180 divided by 3. It'll make it a lot easier for you, okay? So convert those for me. And if you're stuck on dividing, start by dividing by 2 first. Then divide by 2 again if you need to. I don't care how many steps it takes you to reduce as long as you get there in the end. You got him, Tommaso? Okay. A little tired today?
Can you cross out pi because like it's 3 pi over pi? That doesn't work, right?
3 pi over pi?
Yeah, you can't cross out pi, right? You can?
Like 3x over 2. You actually get non-fraction. I would do the dividing first. To make sure like easier because then you have smaller numbers. Alright, looks like we're doing pretty well.
Negative.
Cancel out your pies. I don't. We've played games with it before, just with like wadded up paper, but we should do that. Okay.
Last before Christmas, we have a
Basketball tournament in here, maybe? Yeah. Hot shot contest. I like it. All right, guys. 4 into 180. Again, if you struggle with that division, divide them both by 2. Then you have 2 and 90. And what's 90 divided by 2? So that's a little easier. And then to multiply by 3, do 2 times 45 first, and then add another 45 if you're struggling at all. Okay? Use all those strategies you learned in elementary school. Then the last one, times 180 over 5. How many times does 3 go into 180? So we get negative 300 degrees. Okay, we all right with those? Okay, another definition for us. We're nearing the end, guys. Last definition. We have coterminal angles. So these are 2 angles with the same initial and terminal sides. At different measures. Once you jot that down, then we'll draw a picture. Yes, here, I'll write you a pass, okay? Maybe. Okay, guys, so we actually already talked about a set of coterminal angles at the very beginning. Remember when we drew our 120 degree angle? So this direction was 120 degrees and this direction was negative 240 from the beginning. So do you guys see how those 2 angles have the same initial and terminal side, but they're different angles, right? One's positive 120 and the other's negative 240. That's what coterminal angles are. They look exactly the same, but you can call them 2 different things. Okay? So the way you find coterminal angles is you add or subtract 360 degrees from your angle. Or if it's given to you in radians, what do you think we would add or subtract? What's the equivalent to 360 in radians? 2 pi, yes. So if the question's in degrees to start with, then you give a degree answer. If it's in radians to start with, you give a radian answer. Okay, so let's do a couple of these. Those are your last 4 examples, guys. Well, 1 example with 4 parts. Find a positive and negative angle coterminal to the given angle. So part A we'll do together. $390. 390. Okay, I thought you said 319. Okay, 390. All right, guys, so to find an angle coterminal to that, we can add or subtract 360 degrees. What do you think is going to be the easiest thing to do? Subtract. So let's subtract 360. And what do I get? Okay, there's your positive coterminal angle. Right? Does that make sense? If I drew a 30-degree angle or a 390-degree angle, they'd be in the same spot. Okay, that's what we're looking for. Now I also need a negative angle coterminal to this. So you don't really want to start with the 390 again. Start from your 30 degrees. And how could I find a negative angle coterminal? Yes, subtract 360 from that. So 30 minus 360, what do we get? Negative 330 degrees. Sorry, guys. So that is your positive and negative coterminal angles. So you guys try one for me in degrees, and then we'll do a couple radian ones. So let's say we start with negative 80 degrees. I want a positive and a negative coterminal angle.
I have a question. You're trying to get the positive first, and then the next one you get after is subtracting from the positive.
Not necessarily. You just have to think about how can I get a positive answer and how can I get a negative answer. Yep, there's not like a rule of always do this. Just think about it. Lunch. Okay, guys, let's look. I'm going to add 360 first. It doesn't really matter what you do first. If I add 360 degrees, what do I get, guys? 280. That is your positive coterminal. Now, technically, there's an infinite number of coterminal angles because I could just keep adding 360. I could go, okay, 280 plus 360, that answer, plus 360. Like, you could just go around your circle over and over and over. We're just going to find one positive and one negative, but there's lots of them out there. To get the negative, I'm going to go back to the negative 80 and then subtract my 360. What did you guys get for that? Yes, negative 440. Okay? We got it with degrees? Let's try it with radians. All right, let's say the angle I give you is pi over 3. I don't know why that looks weird. Yeah, what are we going to add or subtract this time?
2 pi.
Okay, so I'm going to write plus or minus 2 pi next to it. And remember that 2 pi is over 1. How do I add fractions?
Have to have a common denominator.
Common denominator. So I really have pi over 3 plus what? 6 pi over 3. Good. And I'm going to say plus or minus 6 pi over 3. Okay, let's add first. What is 1 pi plus 6 pi? So I have 7 pi over 3. That's one answer. And then subtract. What is 1 pi minus 6 pi? Yep, negative 5 pi over 3. I actually think the radian ones are easier. It's all set up for you there. Anybody questions on that one? Let's try one more. Negative 2 pi over 5. Try that. Positive and negative.
It is a little bit quicker.
It is, yeah. Check with your neighbor. Did you agree? Let's go through them up here. Do you guys agree that we're adding and subtracting 10 pi over 5?
Yes.
Okay. So your two answers would have been 8 pi over 5 and negative 12 pi over 5. Yes? Yeah, Alex.
E with negative 80. That's how we have an answer.
So that was the given angle, so it's not coterminal to itself. Because if you did the 280 and subtracted from there, you get negative 80, but that's right back where we started. So it's got to be different than the angle you start with. Okay. All right, guys. Any questions on your notes? Yeah, he does not write his name on it. All right, yeah, I gotta pick the right one for you here. There were no answers given.
Yeah, I have like